Imagine you're ordering your favorite pizza online. You place the order, someone confirms it, it gets prepped, boxed, labeled with your address, and sent through a delivery route, finally arriving hot at your door. What if I told you that's exactly how your emails, Zoom calls, and Instagram messages travel through the internet? In this lesson, we'll explore how digital communication really works through two essential frameworks, the OSI and TCP/IP models. These models are like the behind-the-scenes traffic maps of the internet, and understanding them is key to tracing how data moves and how hackers try to intercept it. By the end, you'll gain a clear, visual grasp of how your digital life travels, layer by layer, and how you can secure it. This isn't just technical knowledge, it's a foundation every cybersecurity thinker needs. Think of internet communication like sending a package across the world. It has to be wrapped, labeled, routed, and handed off safely through several checkpoints. The OSI model is the original way experts mapped that journey. It breaks the process into 7 distinct layers, each with its own job, from the physical cables transmitting signals to the apps you use on your screen. The application layer is where tools like your browser or email live. Below that, layers handle things like formatting, managing sessions, breaking up the data, choosing the best route, and finally delivering through your local connection, like a mailboy inside your building. You don't need to memorize all the layers, but do picture them working together to get your data delivered cleanly and securely. While the OSI model is a great blueprint, the actual internet uses something leaner, the TCP/IP model. Think of it like the highway system that modern data actually travels on. It has only 4 layers, but they do the same jobs as OSI, just grouped differently. The application layer handles your browser, emails, or apps. Transport ensures your message arrives intact. The internet layer assigns addresses and finds routes, like a digital GPS. And network access is the actual connection, Wi-Fi, cables, or mobile networks. You can map TCP/IP to OSI easily. Layers 5 to 7 in OSI are bundled as application in TCP/IP, and so on. While fewer in number, each TCP/IP layer plays a critical role. And knowing them helps you understand not just how the internet works, but where things can go wrong. To make all this less abstract, let's visualize it with something delicious, pizza. When you order a pizza online, you're acting at the application layer. The order gets processed, formatted, and handed to the kitchen. That's like the presentation and session layers. Then the pizza is sliced, boxed, and tagged with your address, transport and network layers doing their job. Finally, it travels through streets and highways, just like the data link and physical layers guide digital bits through cables or Wi-Fi. This analogy shows how your data, whether it's a video call or bank transfer, depends on each layer functioning properly. And just like real pizza delivery, things can go wrong at any step, especially when attackers try to interfere. Now that you see how data flows, let's talk about who's trying to tamper with that pizza. Cyber attackers don't need to break everything, they just need to disrupt one layer. Imagine someone spoofing your address, intercepting the delivery, or replacing your pizza with malware. These are real tactics. Phishing attacks trick the application layer, man-in-the-middle attacks interfere with transport, and malware can corrupt the contents itself. When you understand these layers, you see where things can break, and more importantly, how to defend them. Firewalls, VPNs, encryption, they each protect specific layers. This layered view helps security teams pinpoint issues fast, respond smartly, and prevent deeper breaches. To truly understand how roles like cybersecurity analysts, engineers, and threat hunters operate, you need to think in layers. And that's where the OSI and TCP/IP models become practical tools, not just concepts. Whether you're configuring a firewall, analyzing logs, or hunting down intrusions, knowing which layer you're working with gives you clarity. The OSI model gives you a step-by-step framework, while TCP/IP shows you how the real internet operates. They're both lenses, and when combined, they give you tactical insight into digital movement. This knowledge isn't about trivia, it's about control. control over how you detect, respond to, and prevent cyber threats in a world that never stops transmitting data. Let's tie it all together. The OSI and TCP/IP models aren't just tech concepts, they're the hidden choreography behind every message you send. From emails to payments, your data is always traveling across layers. By understanding these models, you've gained a critical edge. You can see where threats hide, where tools defend, and how systems really talk to each other. Whether you're heading into cybersecurity, networking, or just want to be a sharper digital citizen, this foundation will support every next step you take. In the upcoming lesson, we'll build on this by exploring real job roles that use these models daily.